Hello, fourth graders. I realize, and I apologize, that we've added these challenge problems, but I know that due to time, you haven't had a chance every time to go over them in terms of the solutions. So I would just want to give you an idea of a possible, not just, well, a solution for each one of your problems, but also the possibility of a way you might have gone about solving it the most efficient way. So I've done weeks 18, 19, and 20 for you all in one video. So if you look at week 18, and we look at the first problem, it says, fill in the missing number in each blank space that make the statement true. And we say we want, we want a tens digit of 3 and a singles digit. We want a 4 and a whatever. Well, here's what we have to say to ourselves. Well, it ends in a 2. So what times what allows that to happen? So if we start to think about our different possibilities, well, what if we had something like this? What if you said, well, maybe it's 42 times 38. You're like, well, wait a second. 8 times 2 is 16. Oh, wait a second. That would end in a 6. That wouldn't even work. So I would hope you wouldn't even use 42 and 38 as an option. But if we looked at it and said, well, let's do it this way. What if we started with 32, and we said, well, let's try, what if we did 32 times 46? And as we're doing 32 times 46, the nice thing is we know 6 times 2 is our 12, so which gives us our final digit, our 2-digit, right, which would work. The trouble with 32 times 46, though, is it gives us a final answer of 1,472. And we're looking for an answer of 1,632. So it's like, well, wait a second, that doesn't work. But then what if we say, well, I know there's nothing else because 7 times 2 is 14, 8 times 2 is 16, 9 times... Okay, so I can't combine 32 with anything else. Let's go to the next possible number. So what if we jumped up and said, well, what if I went to 34? And I tried 34, well, times 43, that's actually going to be less than 32, okay? 44, no, 45, no, 46, no, 47. Oh, wait a second. What if I did 34 times 48? Well, when I think of 34 times 48, nice thing is, oh, wait a second. I just stumbled into 1,632. But did I just stumble into it, or did I actually use some number sense to get there? So we know that should be a 4, that should be an 8, and again, it was the digit 2 that helped us. Now, look at the next one. It's saying 4 times n plus 5 equals 48, but remember, parentheses, guys, this all represents one value. So 4 times what value equals 48? Well, 4 times 12 is 48. So we know that n plus 5 equals 12. So then, in other words, n must be what value? N must be 7. Okay, again, just use number sense. It's not algebraically, you haven't worked with distributive property in that fashion to solve it as a two-step variable equation. There's no need to do it that way. Morgan has a collection of Nerf guns. She gave 1/4 of her guns to her father. So 1/4 of her guns, right, went to her dad. She had 2/3 left. So 2/3 went to her sister. So let's let those 2 go to her sister. She kept, right, she kept the 4 remaining. So if that's 4, well, each one of these bars must be 4. So we know that she must have started with a collection of 16 Nerf guns. So that's week 18. Again, these are not the only ways to solve it, but hopefully this at least gave you some solutions. Let's look at week 19. So Taylor read 3/4 of her novel. So Taylor read 3/4 of her novel. So let's look at this. So if you think about the whole book, that's her novel. 3/4 of it was read on Saturday. So this was read Saturday, this was read Saturday, this was read Saturday. Now, then we come back to say that 1/6 of the remaining pages. So all that's left is that final box. So we break this up into 1/6. Okay, so 1/6 of the remaining pages are on Sunday. So in other words, that's our 1/6 right there. She still had 45 pages to read, but that 45 is covered over 5 bars, so each one of these is 9. So 9, and there's a total of 6 of them, so 9 sixes is 54. So 54 in this box, 54 in this box, 54 in this box. 54. So in other words, we're left with 216 would be the total number of pages in her book. Okay. Now, a book is lying open on the desk. The product, we have to remember product means multiplication, of the page numbers shown is 272. What are the 2 page numbers? Well, let's lay out. So you have the pages 11, 12, 13, 14, 15, 16, 17, 18, so on and so forth. Okay? Well, 11 times 12, well, that would give me an indie number in 2, again, using number sense, single digits. But the trouble is 11 times 12, that's only 132. We need 272. That doesn't work. Well, 12 times 3, that ends in a 6. 3 times 4, oh, that ends in a 2. But what is 13 times 14? Right? So if you think about that, that's 13 times 10 is 130. 13 times 4, 52. So it's 182. That doesn't quite get us there. 14 times 15 doesn't end at 2. 15 times 16 does 5 times 6 is 30, doesn't it 2. 16 times 17. Well, wait a second. What's 16 times 17? Oh, 6 times 7 is 42. Oh, that does end in 2. And it gives us 272. So then we know the 2 pages must be 16 and 17. But again, it's just thinking about, the book's lying open, and you're going to see if page, it's page 11 on the left, it's going to be page 12 on the right. Flip the next page, it's going to be page 13 and 14, 15 and 16, so on and so forth. Now, the cows and geese, I think the most efficient way to solve this is actually creating a table and thinking about it. You have cows, you have geese. The most important thing is a cow has 4 legs, a geese, they only have 2 legs. They both have only 1 head, so that doesn't change. So, there's a total of 17 heads, but there's 48. So, if we think about this, if we gave a cow, 6 times 4 is 24. And we need this to be 24, so that would have to be 12. So that would be the right number of legs, but that's not the right number of heads, because 6 plus 12 is actually what? That doesn't work. That's a total of 18 heads. We only have 17 heads. So wait a second. What if we went 6 and 11? 6 and 11. Well, wait. That's 24 still, but that only gives me 22 legs for the geese. That only gives me an answer of 46. So wait, that doesn't work. So what if we had 7 and 10? Oh, well, 7 cows, that's 28. And then 10 would be 20. So wait a second, that is 48. So then we have 17 heads, 48 legs. Oh, wow. So we must have, it says, how many cows live on the thing? There must be 7. Now, Jamie and Rosa are brother and sister. This is one of those ones where it's literally you having to lay it out as almost as boxes, saying, well, if we have Jamie and we have Rosa, well, right off the bat, Jamie and Rosa are brother and sister. Jamie has the same number of brothers as sisters. So for him, brothers and sisters are equal. But the thing is that Rosa has twice as many brothers as sisters. So when you start laying it out, well, if Jamie had a brother, remember Jamie being a boy, and you start saying, well, we have brother, sister. We have brother, sister. We have brother. And so let me show you what I'm doing here. And this is, I'm sorry, this should have been separate. I apologize. I ran out of space on the bottom of my page. So we know if Rosa looks up, because Rosa's a girl, right? So that means she's her own sister. So in this situation, when we're looking at this conversation, we know that this is Rosa here. That's Rosa. So in this situation, she has 2 sisters and 4 brothers. Oh, that meets that requirement. Now in this situation with Jamie has the same brothers and sisters. So in this situation, imagine we wouldn't this for Jamie's sake wouldn't be there, right? So Jamie would be this brother. So then he has 3 brothers and 3 sisters. Whoa, that meets the requirement of 3 brothers, 3 sisters. So ultimately, you find out that there's 4 boys and 3 girls in the family. That's definitely very critical in terms of how you laid it out. Definitely helps with that problem. Let's look at our week 20. So Mrs. Hunt planted peonies in her garden. I know when you first got this problem, I am so sorry because I left out a number and I know you couldn't solve it. I'm sorry for that. And I'm so happy we had a young man in 4th grade come to me and say, Mr. Harrison, and I said, thank you so much. So we have Mrs. Hunt planted peonies in her garden. Of all the peonies, 1/3 were red. Of the remainder, and I apologize, I don't have my glasses on, so let me look at that a little closer. 3/5 were pink and the rest were white. If she had 45 red peonies, how many of the peonies were pink? Well, she planted peonies, right? 1/3 were red. So if this was, and that's the red ones, 45, then this would be 45. This would be 45. So in other words, this is a total of 90. That would be 90. Then, from that, we know that 3/5 were pink. Well, if we took 90 and divided it by 5, each one of these would be a number of 18. So if we had 18 plus 18 plus 18, so we know there must have been a total of 54 pink. Now, with Bradley mowed 2/3 of the lawn and Bradley mowed 2/5 of the lawn and Alex mowed 1/3. Well, 2/5 and 1/3, we can't solve this without letting the lawn be the same, equivalent value, which would be our common denominator. So we know that, and remember, we use identitive property. So 2/5 times 1 creates our equivalent fraction of 6/15. 1/3 times 5/5 is 5/15. So we know 6/15 minus 5/15, we know it must be 1/15. So 1/15 was the difference in the cut in the grass. Now, I'm a magical 3-digit number. There's my 3 digits. My tens digit is half my ones digit. The sum of my digits is 13. My hundreds digit is the first counting number. Well, the first number you learn to count with is number 1. So that's the key thing to make this work. Now, what plus what? So if I think of half, well, half of 6 is 3, but 6 plus 3 plus 1 is 10, not 13. Half of 8 is 4. 8 plus 4, oh, that's 13. So if we go back and think about it, my tens digit is half my ones digit. My tens digit is half my ones digit. So I know my answer must be 148. And then the last problem, suppose you have 15 marbles, you have to put those marbles into boxes. Well, the neat thing is here, each box holds a different number of marbles. So what if I put 1 marble in the first box? Then I put 2. then I put 3, then I put 4, then 5, then 6, then 7 marbles, then 8 marbles, then 9 marbles. Well, if I did that, that would be a total of 45 marbles. Because if I went to the next box and put in 10 marbles, that would be 55. I only have 50 marbles to work with. So once I got to 45, because every box holds a different number of marbles, I'm trapped. I can't have a box with 10 marbles, and I can't have another box with the 5 marbles I've left over, because then now it says that everyone's different. So now I know I can make a total of 9 boxes of marbles. So I hope this gave you, at least the solution to these problems. And every couple of weeks I'll continue to send this out the rest of the year, okay? And if you have any questions, please ask. Thanks, guys.